Let's start solving this problem by redrawing the circuit using the equivalent capacitance and the equivalent resistance. I've shown those two here. We can notice that the two capacitors in the problem are in parallel, so the equivalent capacitance is the sum of those two, and the two resistors are in series, so the equivalent resistance is the sum of those two. This is an RC circuit, so we can calculate tau, the RC time constant, multiplying the resistance times the capacitance to find it equals 2.80 milliseconds. We also know that the voltage across the capacitors at time 0 is 45 volts. To solve part A, we'll use the fact that the voltage across the capacitor in an RC circuit decays exponentially according to this expression. Here we're asked to find the time t when a certain voltage is reached, so we'll rearrange this equation and solve for that time. First divide by the voltage at time 0 and take the natural log of both sides to eliminate the exponential, and then solve for t using the negative sign to invert the argument of the natural log. That gives us this expression, which we can substitute our values into and find that the capacitor voltage is 10 volts after a time of 4.21 milliseconds has passed after closing the switch. Part B asks us for the current through the switch at that same time. We can solve that using the fact that the current in an RC circuit decays in the same way as the voltage. So that's given by this expression, where the current at time 0 using Ohm's law is the voltage at time 0 divided by the resistance. So now we can evaluate the current at the time of 4.21 milliseconds, finding that it equals 0.125 amps.